Hi guys, my name is Ivo and I'm from mytestedasp.net. In this video, I'm going to teach you dependency injection and dependency inversion containers in the most simple way possible. But before we begin, make sure you hit the subscribe button and turn the notifications bell on so that you won't miss any of my future C# lessons. Let's start. We have the following solution here. We have a simple system which follows the normal practice from a normal web application. For example, we have a cat service which has some business logic. We have a database, and our database essentially returns some cats from the database. I'm using an in-memory collection. The database uses an appsettings file which provides the connection string, and pretty much that's it. The database model cat has an ID, name, and property added on from of type datetime, and we have a cat result which the service returns. So the logic here is that we have some method and which gets random cats from today. So the whole idea here is to get all the cats from the database which are saved in the current day. So the logic is we create a database, we initialize the date time now, and we get the beginning of the day, of the current day. We have a new random. The random number is fixed between 10 and 50, and we perform a database call which gets the cats, filters them, then takes the total cat names, and then selects the cat result. This should be total cats, I guess. It's a better name. Okay, that's a normal application flow for a web application, for example. So we have business logic, we have a database, and some other uh, classes which we use. For example, the random class, that's an infrastructure class. It helps us get a random number. We have application settings and so on. Okay, so this example here does not use dependency injection, and before we start showing how we can refactor it with dependency injection, we should first explain what a dependency is. A dependency is every other component which the current class is using. For example, the DB context has a dependency on the app settings file. So this is a dependency. Then in the cat service, we have a dependency on the DB context. We have a dependency on the current date time. We have a dependency on a random provider, and we have a dependency on the cat result class, which is just providing the names from the cats. Okay, great. So this is a dependency, and dependency can be everything our class uses, from frameworks, from third-party libraries, from system resources like the datetime, from configuration files, from the file system, a lot of stuff. So what we want to do to make the code better is to use the principle dependency inversion. The whole idea is that instead of let the class define its dependency throughout the logic, we extract the dependencies from the class and let the class receive these dependencies from outside, usually through the constructor. And the whole idea here is that we want to enable the outside world to see what kind of dependencies the cat service is using and what kind of dependencies it needs in order to work correctly. We have better documentation this way because when we are creating the cat service object, we already know that it needs a database. Otherwise, it stays as a hidden dependency. Also, another thing is that we can easily replace these dependencies in the future or in our tests. Currently, the cat service is bound to this DB context and we cannot change the database provider. For example, if I have a file full of cat information, I cannot replace this DB context with a file provider easily without changing the whole class here, without making a huge difference. Also, I cannot currently test the class because the class does not use um, the class don't allow me to replace the DB context instance. It does not allow me to replace the current date time, the random provider, and so on. So essentially, this method here is very difficult for tests, but it also has so-called hidden dependencies. Hidden dependencies are usually identified by the new keyword. Every time we use the new keyword in a method of our business logic, we're using a hidden dependency. Also, every time we have a static class, we are also having a hidden dependency. It's always better to not use static classes and extract them to instance wrappers in order to uh, make our system more flexible. Currently, it's not flexible at all. I cannot change the random provider, so I cannot test that. I cannot assert randomness uh, in no way. Also, I cannot assert the datetime now property. I cannot replace the DB context with a fake database which I want to use for tests. So what I need to do is I need to extract these dependencies and make them external. Usually this is done through interfaces because interfaces are abstractions and they allow us to create and to replace these dependencies very easily. So let's start with the DB context. The DB context has one dependency and that's on the app settings. Of course, it has a dependency on list and on cats, but I don't want to replace that. I don't have uh, I won't have any positive side effect to replace these things. So the only thing I'm using here is the app settings class, which is a hidden dependency for my DB context class. So what I need to do is I need to introduce an interface which is called iAppSettings. And what I need to do is I need to provide the same functionality as the class itself, as the specific class. And then I can use this interface in the constructor of my class and then use it directly in my logic. This way, we abstracted the dependencies and now everyone using the DB context should know that this class needs a app settings dependency. So let's go to the cat service and see how this changes. Unfortunately, we cannot use the DB context directly, so what we need to do is provide an app settings file here. This will get better, I promise. New app settings file, but we need to say that this class implements the iApp settings file. So it starts working. Other thing you can do, which is the so-called poor dependency inversion, poor man's dependency inversion, is adding an empty constructor calling the other one with some sort of default implementation like this. This way we can create the DB context without providing an explicit dependency here, but we can also change it if we like. But this is poor man's dependency inversion, so don't use it. I will show you a better way. Okay, for now, let's say that I'm going to need an app settings file. So I'm going to pass it here. And the code will continue working, but currently, when I'm using the DB context, I know that this DB context needs a configuration file, so I need to provide it. Great. Then let's fix this method right here. Currently, it has a database dependency, an app settings dependency, a datetime dependency, because it's a static class here, and a random class dependency. So these are the main dependencies I need to replace. Also, I have a dependency on cat result, but this class is only a data transfer object. This is a best practice when transferring data from a layer to another layer. So this class does not have any logic. It only serves as an object to transfer data. So apparently I don't need to replace that because it doesn't have any specific logic in it. Okay, let's create first a DB context interface. DB context. This will be an interface which allows me to have a list of cats. I'm going to make my DB context implement the interface, and then I'm going to say private read-only IDB context, for example, database, and I'm going to initialize it from the constructor. I'm going to say IDB context database. I'm going to say this database equal the database, and I'm going to remove this direct dependency here. So from now on, this class uses an abstraction, an interface, and it doesn't have a concrete implementation. So if I want to create iFile database context, and if I implement this interface here, the logic here will continue working. And that's the whole idea of dependency inversion. Models to depend on abstractions and to be able to easily replace them. That's the whole idea. So let's see how I'm going to use that. So what I will need is I will need a new DB context. So I'm going to say create a new DB context, but the DB context needs an app setting file. And done. It's working. And if I run the code, it works correctly. Let's extract the datetime and the random provider, and we're done with this class. Then I'm going to show you how easy it is to replace the logic, and then I'm going to show you how to skip the whole initialization phase like this, because this, unfortunately, with huge code bases is not applicable. If you have 5 dependencies on each class, you will go crazy of creating new instances of every single dependency. So we have tools which help us to replace that. Okay, so cat service, I will need to add a random provider And this random provider will just say public interface iRandomProvider, and it will return a number like this. Since the random class is not part of my code base, I cannot implement interfaces directly here. So I will need to make a wrapper class, which is called a random provider. Of course, why not? And I will implement the interface, and here I'm going to private static read-only random, like this. Suggest the name random, so I'm going to reuse it, and I'm going to wrap the logic behind the random numbers. Random.next min max plus 1. Plus 1 because the original random provider does not include the value provided here. Okay, so in the cat service, I can now replace the random provider. I can say I want to have random provider, like this. Then I'm going to inject it. This is why it's called dependency injection, because essentially I'm injecting interfaces and classes through the constructor. Random provider. The whole idea behind extracting dependencies and make them be provided from the outside world is called dependency inversion, because we're saying, okay, the class no longer has dependencies instantiated directly in the code. It will get them from the outside world, from the client code. This is why it's called dependency inversion. And dependency injection is automatically providing classes here without me worrying how to instantiate them. But I will show you that in a minute. Okay, so let's replace the logic. What I need to do is I just need to say this dot random provider number between 10 and 50, because that was my original logic. I'm going to use 50 here and not 51 because the random provider class will add a 1 for me. Cool. Let's create the random provider here and let's use it. And the last dependency we have is the static datetime now. So I'm going to create a new interface, current time provider, which is going to give me the current date time. Date time now, like this. Then I will need to current time provider. I will need to create a wrapper class because datetime now is part of the .NET framework and essentially it's a third-party tool and I don't have the access to the code base. That's not a problem. I'm just going to reuse datetime dot now or UTC now if that's the case, but it was originally datetime now. Okay, then I current provider. What I need to do, I need to go I need to go to the random cats from today method and replace the datetime now. So what I need to do here is I need to say I need current time provider like this. I will mark it as a read-only field here, and I'm going to say current time provider equals current time provider, and the datetime now part will now be from the current time provider dot now interface method. And that's it. We fixed all the dependencies, and now we have inversed dependencies. Everything is provided by an interface. It's easily replaceable, and this class now shows what it needs in order to work correctly. It needs a database, a random provider, and current time provider, which is quite cool. The last dependency here, we don't need to replace that. Okay, great. Now let's fix that. Var current time provider equals new current time provider. And let's pass it and make sure that our project is working. So let me show you some other things. You can use classes directly. That's kind of okay because currently we also have inversion of dependencies. We are saying, please give me an instance of the DB context, and that will continue working. So that's completely fine if you decide to use classes here. The only problem when you are not using interfaces is that the logic behind the class is not replaceable. So if you want to test with fakes or mocks some objects here, you are not going to be able to do so because you cannot replace the DB context methods directly. But if you have an interface, that will be very easy to do. So it's preferred to make everything abstract and have interfaces because this way uh, your system is more flexible. For example, let's make a file DB context. File DB context, which will get the data from some files. So, for example, let's say that this logic here is to have var cats equals file read all text from cats.txt, then split them by environment new line. For example, every new line will have a new cat. Then what we need to do is for each cat in the cats, like this, cat text. For each cat text, we want to create a list of cat. And for example, I'm going to parse that, and I'm going to say that var cat parts equals cat text dot split by dash, for example. Then I'm going to say cats dot add new cat, which has int parse cat parts from 0. Then name is cat parts like this, and added on is datetime dot parse exact, And I'm going to say that I want to have get parts from 2. I'll need some format, for example, like this, 1 month, and then I want this, like this. And culture info invariant culture, like this. Then I'm going to well, that's not too ugly, so I'm going to use it. ReSharper is being smart again, so what I can do apparently is I can reuse everything, can make it on a single line, and I can make it as a lambda expression. Okay, that's the logic behind the FileDB context, which essentially gets gets cats from file, and the normal DB context gets cats from an in-memory database. But the cool thing here is that I don't have to change the cat service implementation to work with either of these databases. What I need to do is just I need to say, okay, man, start using the file DB context and everything will be fine. And the cat service logic will continue working without knowing that the database is now different. That's the whole cool thing about the flexibility of the dependency inversion. Okay, but in a huge solution, these uh, creations of objects will get very difficult when the classes starts getting bigger, because bigger classes have more dependencies, their dependencies have even more dependencies, and so on. It starts getting very tricky to create a new object because the constructor expects 81 dependencies in total. So how to fix that? In order to fix that, we need a dependency injection container. And with the dependency injection container, we can easily register our dependencies and they will be used for us. Let me show you how this is done. We need to install some sort of dependency injection container. There are quite a lot of options available for dependency injections containers. For example, Ninject. For example, Autofuck. For example, Unity, like the famous engine, game engine. And I'm going to use a tool called Simple Injector. It's very easy to use, and since we want to be as simple as possible in this video, let's use it. I don't want to overcomplicate the dependency inversion principle and the dependency injection itself. Let's make it as easy as possible, and if you need more information, you may find it or learn it as you try to use dependency injection. Keep in mind that I'm showing constructor injection here because I'm injecting my dependencies through the constructor. This is by far maybe the best possible scenario, but there are also property and method injections. If you want, I can make videos about them, but if you understand the whole concept of the dependency injection principle, uh, you get how to easily do it with properties or methods. So this is why I decided to not overcomplicate this video. But before we continue with the simple injector, I would like to show you where you can find the source code from this video. The source code from this video is available on my GitHub profile. It's Ivai Lukanov. You may follow me if you like. You need to hit repositories, then write down TV here, and that's the repository which contains all my lessons and all the source code I'm using in these lessons. I will be extremely thankful if you give the project a star. It will be a huge help. You may also watch this repository if you want to find about my lessons in advance, because usually I commit the code here and link the video before I publish it on YouTube. So you will learn a bit earlier when I publish a new lesson. Here you can download and play with all the source codes I'm using in my YouTube videos. And here you can find all the playlists, all the previous lessons, and so on. Everything structured in this README file. I would like to also thank my sponsors, which are Bellatrix, ReSharper, Softuni, SmartIT, Noblehar, and 1-Bit Software. Thank you guys, you truly rock. I'm extremely thankful for your support. That's Bellatrix, JetBrains and ReSharper, Softuni, SmartIT, Noblehar, and 1-Bit Software. Thank you guys, you rock. Let's now return to the simple injector. What I would need is the so-called container class. I just need a new container from the simple injector. Then in the container, I need to register all my dependencies. For example, what I need to say is, I can say container register I app settings to the app settings class. App settings, not app context. Like this. Then what I can do is I can say container register I db context as db context or the file db context, depending on what I need to use. Then I need to say the iRandom provider is registered as random provider, and iCurrent time provider is this class. And I no longer need any of these instantiations here. The whole idea is that I'm saying that to the container, whenever some class needs an iAppSettings interface in its constructor, give him a new instance of appSettings. Every time a class needs a idbContext interface, pass him a dbContext class, and so on. That's the whole idea. I register my dependencies here and how they should be resolved, and I leave the container to do that for me. It resolves recursive dependencies, so everything in the dependency tree will be resolved if that dependency, of course, exists. So then what I need to do is say container.verify, which will verify whether the interfaces are correct and can be resolved. That's the whole idea here. Then what I need to do is, instead of creating a cat service directly, I can say container get instance of cat service, like this. And this is my cat service. So my container has the task to resolve the cat service class and find all its dependencies from the registered interfaces here. And if I run that, it should continue working. Here it is, my cool cat. And if a dependency is missing, it will throw a great exception which will describe that no registration for type cat service could be found. The constructor of type cat service contains the parameter with name database of type IDB context, and IDB context is not registered. So what I need to do is just provide a class for that IDB context interface, and the simple injector will start injecting it for me. As you can see, it resolves the DB context recursively because it finds the IAP settings class and creates it. So pretty much that was it. Of course, you have more advanced concepts, for example, the lifestyle, scoped, singleton, transient, and so on, but these are more advanced. The whole idea behind that is to say, if I provide a class to the for the dependency, when I should destroy it. Is it a singleton? Is it only one per application? Is it a new object every time you need it? And so on. That's the whole idea. But of course, you can read more about it on the documentation of Simple Injector. The whole point of this video was to show you what dependency inversion is, how to extract dependencies which are hidden in your classes and make your classes have explicit dependencies in the constructor, which allows them to be well documented, because when you use the class you see what it needs in order to work correctly, and allows you to be more flexible and depend on abstractions, which gives you the freedom to replace these dependencies every time you need. Okay, that was it, guys. I hope you liked this video. Hit the thumbs up button and make sure you subscribe if you haven't done it already. Make sure you also turn on the notification settings, because you don't want to miss any of my future videos. Before I finish, I would just like to show you my testing tools, which I create in my free time. They're very advanced and allow you to write very fast and very easy assertions for ASP.NET and ASP.NET Core. You can validate your controllers, models, services, everything your web applications has, and it's written in a very simple and fluent manner so that it happens in a matter of seconds. People report great success with these tools, so if you need to test your ASP.NET project, make sure you give my tools a try. Also, since these projects are currently developed in my free time, I would like to invite you to become a backer or sponsor. So if you like this channel, these lessons, if you find them very useful, or if you like to support my projects, you can do that by either sharing this video with your friends, by donating on Patreon or Open Collective, or even a one-time donation on PayPal. Everything is fine. So some people and companies already did that. I will be extremely thankful if you just spread the word, give a star, whatever you can do. Thank you and bye.